Hi guys, welcome back. So in today's video, we're going to be working with binary trees once again, but this time we're going to be working with two other types of traversals called preorder traversal and postorder traversal. So if you watched the last video in which we did the in-order traversal, these next two types of traversals will be very similar. They're just going to be going in a slightly different order. And if you haven't, go back and watch that. But basically, what a pre-order traversal is, what happens is in our in-order traversal, we print out our string, the data element of our node after we check and go through our left node. So in this case, if we were at our self.root, we would first check to see if there's a left node, and then if there's a left node on this 2, we would go to that left node, which in this case is the 4. And since there's no there's no left or right node for the 4, we print out the node data for the 4, we go back up, we print out the 2, and then we check to see if there's a right node on the parent, which in this case was the 2 because the parent of 4 is a 2. And then we do the same thing on the 5, we go back up, we go to the 1, and then we do the whole thing again on the right side of our list, of our binary tree. But one difference in a pre-order traversal is that in a pre-order traversal, we are first printing out the data element of our root, and then we're going to the left side. And so I think first it'll be easier for us to code it up, and then we'll kind of talk about what's happening. And so this pre-order traversal method, each traversal is going to have two methods, just like our in order. There's going to be an actual method and then a helper method. And so in this one, we're going to say initialize with string again, and then we're going to return self.preorder helper, and then we're going to pass a string and the self.root. So this is going to be, that's just going to be the traversal method. And in the helper, what we're going to say is if there's a node, we are going to first add to our string by printing out the node.data plus the dash, and then we're going to say string is equal to our self.preorder helper node.left, and then just copy that over and we do the right. And if there's not a node, or once we finish that, we're just going to return the string. So what's happening in this case is in our preorder, basically what happens is in our in order, the reason it's called in order traversal is we go left, then our root, and then our right. In our preorder traversal, we're first looking at our root node or our parent node, then we're looking at the left and right. And then when we get to the post order, you'll see that first we look at the left, the right, and then the parent or the root. And so preorder is basically saying that our parent node, we're going to look at the parent node first, as opposed to looking at the left node first or whatever the case may be. And so in this case, what happens is if we start off at our self.root, we print out our data element for our root node. So this is going to print out the 1, right? And then once we run that, we're going to go to the left node and we're going to run it again. And so we're going to go from the 1 to the 2 because the left node of the 1 is a 2. And then we're going to run the whole thing again. If there's a node at this position, we're going to print out the data element for this node, which is the 2, and then we're going to run this preorder helper on the left node of our 2 once again. So we're going to go down, that's going to be the 4, and we're going to check once again. Is there a node at this position? There is. And so then we print out the data element of the 4 node, which of that node, which in this case is the 4. And so once we do that, we run it again on the node.left. There is no node.left for our 4 node, so it's just going to return this string. Do the same thing with our right node. There is no right node for our 4, so we're just going to return the string. And then we're going to go back up to our parent node, right? Because in this case, when we were at the 2, we ran this line of code. That's how we went from the 2 to the 4. So now what we need to do, we need to run this line of code. So we need to look at the whole right side of our 2 node. And so, or in this case is the 2 node, but what really is the parent node. And then what happens is we go back. sorry about that. We go to our 5, which is the right node of our 2. We print out the data element. So we print out the 5. We add the 5 to our string, and then we do the same thing. We check if there's a node dot left. There isn't. We check if there's a node dot right. There isn't. So in both cases, it returns a string. And so now we've checked the 4, the 2, the 5, and then we go back up and we're at the 1. And so what happens now? At the 1, we ran this line of code and we went to the left side of the string of the binary tree. Now we have to run this line of code on the root node and do the whole thing again on the right side of our binary tree. So we go to the 3, we print out the node.data. We check if there's a left node. There is. So we go to the 6, check if there's a left or right. But before that, we print out the data element, which is 6. So we print out the 3, the 6. There is no node.left, no node.right. So we go back up to a parent, go up to our parent. We need to run this line of code on our parent because when we were on the 3, we ran this. That's how we went from the 3 to the 6, but we still need to go from the 3 to the 7. So we go to the 7 and we print out the data element, check if there's a left and right. Since there isn't, we have finished our whole preorder traversal because we've gone from our self.root all the way through the left side, all the way through the right side, and that's the end of the preorder traversal. And so if I comment this out and comment this out, and I type in Python bt.py and we run it, I get one error. And let's see where the error is. String is equal to preorder node.left. Oh, I forgot to pass string in here. String. So remember, this takes a string and node, and so we have to pass in the original string and the node that we want to enter. So if we run that again, we get 1, 2, 4, 5, 3, 6, 7. So this is what we talked about, right? First we went through and we printed out the 1, then we went to the left side and we printed out the 2, and we checked to see if there's a left or right node. There was, so we printed out the 4, but since there was not a left or right node on the 4, we went back up to our parent, which was a 2, and we went to the right side of that parent, which in this case is the 5. And since there was no left or right of our 5 node, we went back up to our parent, which was the 2. We ran all three lines of code on our 2 node, so we went back up to our root node. But in our root node, we still need to do the same thing again on our right side. So we went to the 3, printed out the 3, went to our node.left, printed out the 6, and checked if there's a node.left and node.right. There wasn't, so we went back up to our parent, which is the 3, and then we went to our the right side of the parent node, which was the 7, and we checked there's a node.left and node.right on the 7 after we printed out the data element or added the data element of that node. And that was the end of the binary tree. We went through every single node in the list, in the tree, and so we got the exact same order that we were expecting. So that is just preorder traversal. Postorder traversal is very similar. Like I said, all we're going to do is instead of printing out the data element of our parent node at the very beginning, we're going to print it out at the very end. And so what's going to happen is, once again, we can say string is equal to an empty string. We'll return post order self.postorder helper, pass a string and self.root. And then what we're going to do, if there's a node, we're going to say string is equal to self.post order helper of the string and the node dot left. Copy that. Do the same thing on the right. Node dot data plus the dash, and then we'll return the string. So what this is doing is when we start off at our self.root, we want to print out our root node at the very end instead of the middle or the very first. And so what's going to happen now is if let me label this preorder. And then now what we'll do, we'll print out what we should expect for our post-order traversal. And so we start off at our self.root over here. We check there's a node at this position, and then we run these lines of code. So first we want to check if there's a node.left on our root node. So since there is, we're going to go to the 2, and we're on this node now. If there's a node at this position, we're going to run these lines of codes again, right? And so we check if there's a node.left, or we run it on the node.left. And since there is, we're going to go to our for node. And in this case, we're going to check if there's a node.left. There isn't. We're going to check if there's a node.right. There isn't. And so in both cases, it's just going to return the string. And then this is the first time we're going to be adding to our string. So when we get a result, it should have the 4 at the very beginning. And so then what happens is once we've ran the 4, we've ran all these lines of codes on the 4, we return the string. We go back up to the parent, and we do the same thing on the right side, right? Because we go from the left to the right. We don't want to print the parent, the data element of our parent node yet. And so we do the same thing on the right side. We check if there's a left and right on the 5. There isn't. And so since they both return string, now we're going to add our second part, or our second addition, which is going to be the 5. And then now we're going to go back up to our parent node. So on our parent node, we ran the node.left. We ran this on the node.right. Now we're going to add our third addition to the string, which is that node, which is going to be the 2. And then we're going to go back up to our 1. And remember on the 1, we ran this first line of code. That's why we went to the left side of the binary tree. Now we have to do the same thing on the right side of the binary tree. So we do the same thing. We go to the 3. We check if there's a node.left. There is. So we get to the 6. There's not a node.left, no node.right. So we print out the data element. Add the 6. Do the same thing on the right side of the parent. No node.left, no node.right. Print out the 7. Print out the 7 over here. Then once we get back up to our parent node, after we've gone through the node.left and node.right, we print out the node.data of the parent node, which is the 3, because we've looked at the left side and the right side of that parent node. And once we've done that, we're back up to our self.root, and on our self.root we ran the node.left, ran the node.right, and now all we have to do now is just print out the node.data of our root node, which is v1. And so this is the order that we should expect for our post-order traversal, and hopefully that is what we get. And so what I'm going to do is comment this out, and then run it, and let's compare. We get 4, 5, 2, 6, 7, 3, 1. So that's the exact same thing we got on our post-order traversal. So I think one of the main things that helped me remember the differences between these is the location of when we're printing out our parent node's data. So in the in-order traversal, it's in between. First we do the left, print out the root, then print out the right. In our pre-order, we're printing out the root node first, and then we're looking at the left and right sides. And then our post-order traversal, we're looking at the left side, the right side, and then we're printing out our our parent node at the very end. And so that is the three of the traversals that you can do to print out all of the data elements in the binary tree. And hopefully this video helps you guys, and see you guys in the next one. All right, later.